Good day to you. This is another time for you to learn something on maths appreciation. Today we'll be talking on some standard derivatives that will help us to understand how we can differentiate some other kinds of functions we've not talked about, like product of functions, functions of functions, and quotient of functions, which we'll discuss in due course. Now we want to talk on some standard derivatives. There are some results that are already established, and these are the things I want to present to you. And the result will help us to further know how to differentiate some functions. Number one, if you have a function sine x, it's already an established result that the derivative of that particular function sine x is cos x. So if you have another function cos x and we are asked to differentiate it, is a result that has already been established. So the derivative of cos x is minus sine x. The same thing is the derivative of exponent of x is the same thing as exponent of x. If you differentiate tan x, the result is sec squared x. These are some of the standard results that will guide us to differentiate some other functions that we'll discuss in due course. The first one we need to consider here is products of functions. If we have a function which is a product of two functions, y equals x cubed sine x, how do we differentiate this kind of function? All right, we have a function here, x cubed, being multiplied by another function, sine x. So it's a product of two functions, 1 and 2. So they are here. So we have a particular approach we need to use to be able to get the derivative of this function. So to obtain the derivative of that function, we say dy all over dx is equals to u dv over dx plus v du over dx. In this case of y equals x cubed sine x, we could say that our u equals x cubed and our v equals sine x. So if we use this formula now, dy respect to dx is now equals to x cubed. If we differentiate this particular function v, which is sine x with respect to x, is cos x plus, if we differentiate this function now, u with respect to x will now give us, v will be here, of course, sine x will be here. We differentiate this guy now, du with respect to x, where u is here, will now have 3x squared. So the derivative of the function y with respect to x is now x cubed cos x plus 3x squared sine x. At this point, we've been able to differentiate this function y cubed sine x. This is a sort of recap. We want to go back to the steps we use to differentiate this function. We use this formula now to find the derivative of this particular function, x cubed sine x. We call this particular x cubed u, and we call sine x v. So if we differentiate this function u with respect to x is equals to 3x squared. Just the normal way we differentiate a polynomial. And if we differentiate v with respect to x, this is cos x. So if we substitute these two guys in this function, we now have what we have here. And we perform the simple arithmetic by taking this one this way, and we have here. Therefore, dy with respect to dx is now x cubed cos x plus 3x squared sine x. Thank you very much for watching until this time. With this particular illustration or example on the board, I know you've learned how you can differentiate the product of two functions of this nature, x cubed times sine x. The function could be of any form. You know how to use this formula, which is called the products rule. We call this particular formula the products rule. To differentiate this function. You know, you've learned something. Thank you. Please kindly share, like, comment, and make sure you subscribe to our channel. Thank you.